Hey, what's up, guys? Welcome back. Hope you guys had a good weekend. Hope you guys are staying safe. Alright, we're back with lesson number 3. We're going to be modeling with quadratics today. So, I don't know if you remember, but in class one day, I drew a ball or something like a ball. I don't remember what I drew. I drew something over my desk. And we were all amazed because that thing I drew followed the perfect path of a parabola. And what we said, if that's a parabola, isn't there an equation? And if we have an equation, we can model the path of that ball with an equation. And that's what we're going to be doing today. We're going to be modeling quadratics with equations. So we're going to represent things like the height or the path of a ball with quadratic equations. Alright, so everything we've been doing for I don't know how long now, for quite a while, right? We're going to put it to use to figure out things in the real world. Alright, so we got the science class. They're designing a ball launcher and they're testing it by shooting a tennis ball off the top of a 15-story building. The height of the ball at any time is modeled by that function, where t represents the time in seconds after the launch, and h of t represents the height in feet of the ball above the ground. Alright, so I'm just going to copy this equation they gave us, and let's really break down the parts of it and what the heck it means. Alright, so first of all, function notation. So h of t, they said h of t represents the height in feet. Alright, so this is the equation for the height of something. So this h of t, that represents the height in feet. So how high this ball is depends on t. And I know that because t is the input. So t here, that represented the time in seconds. So what this equation is giving us is, it's telling us plug in some time in seconds. So you can plug in 2 seconds, 3 seconds, 4 seconds. And what we're going to get out is h of t. We're going to plug it into this equation, some time t, and what we're going to get out is the height in feet. Right? So let's draw a picture of what's going on here. We have a building, a 15-story building. I'm going to draw in some windows. Just drawing a nice door here. And we got this ball launcher. I don't know what the ball launcher looks like. Maybe it looks like this. And it doesn't matter if they shoot it straight up and it comes straight down, or they shoot it to this side or that side. But to make things easy for us, and so we can get a good visual, I'm going to draw it being fired at an angle off the building, and it's going to fall off the building, and it's going to hit the ground at some point, of course. So let's say it looks like that. And here's the ground. And there's the path of the ball. Right? And bam. Strikes the ground after however many seconds. Right? When it hits the ground, its height is going to be 0. And that's what's happening. So, let's take a look. Letter A, find h of 1. What does this represent? So function notation, h of 1 is going to equal, well, that's telling me to just plug in a 1 for t, wherever I see a t, right? So let's just do the math first, and let's see what this means after. So I'm copying my function. Actually, erase this too. Let me copy this entire thing. H of t is equal to that. Don't like that plus sign. All right, h of t is equal to that. So what is h of 1 equal to? Well, that's telling me to plug in a 1 for t. So instead of t squared, I'm going to have 1 squared, right? 144 times 1. Right, so h of 1 equals negative 16 times 1 is negative 16 plus 144 plus 160. And I think if we do that in the calculator, let's see what we got. That looks like 288 to me. Alright, so h of 1 is 288. So what did we do? We plugged in the 1. Well, what do we plug in 1 for? When we plugged in the 1, we plugged in the 1 in for t, right? So that 1, that was time in seconds. So that means after 1 second, well, we saw h of 1 is 288. After 1 second, the h value is 288. Well, what did that represent again? Right, that is the height in feet. So we found after 1 second, when t was 1, the height at 1 second was equal to 288. So after 1 second, the ball is 288 feet above the ground. Alright, and so let's find h of 3 now. So same idea. In fact, I can copy and paste the same function. Instead of plugging in a 1 though, we're just going to be plugging in a 3. Alright, so h of 3 would be negative 16 times 3 squared plus 144 times 3. And, hold on, I have this somewhere. What is that equal to? If you're going to type this into your calculator, I highly recommend practicing that. Right, make sure you're using your parentheses. You can type it all in one go, or you can break it up into pieces. But h of 3, hoping you guys are getting 488. Right, let me just double check that real quick. Not 88, sorry, 448. Good thing I double checked. Alright, so same thing as the first one. It means after 3 seconds, the ball is 448 feet above the ground. Alright, so by the way, this is something you can also do in your calculator, of course. If you graph the function, right, and you look at the table, you would see 3, 488 in your table. You would also see 1, 288 on your table. Alright, so what is the initial height of the ball? So what do we mean by initial height? Well, we mean the height at the very beginning, the height right here. So if we imagine this with a XY axis drawn in, right, I'm going to draw my y-axis so it goes straight through the ball launcher. Because I think it makes sense to call that times 0. So this point right there, wouldn't that be like 0, 0, if that's my x-axis and that's my y-axis? So the initial height is going to be this point. That's going to be, well, 0, whatever this y value is. So if I'm looking for the initial height, well, aren't I looking for the height of this ball at time 0? Right? Initial height is the height at time 0, or when t equals 0. So I can use my same equation one more time, except this time, instead of plugging in a 1 or a 3, which would tell us the height after 1 second or 3 seconds, to get the initial height, we're going to plug in a 0. So that's going to be 0 squared plus 144 times 0. So negative 16 times 0 squared is 0. Negative 16 times 0, that's going to be 0. 144 times 0 is going to be 0. And we're going to be left with just 160. Right? So h of 0 equals 160. That means the initial height at time 0 is 160 feet. Right, so we could just keep plugging in numbers all day, and that would give us the height after whatever we plug in. We can plug in after 1 second, after 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. Plug in a 7, you get the height after 7 seconds, etc. Right, so we could keep plugging in. Maybe eventually we'd figure out when the ball hits the ground. So what do we mean by when does the ball hit the ground? Well, the ball is going to hit the ground maybe somewhere over here. And by the way, let's label this point. What do we get? We got 160, right? So at 0 seconds, this height represents 160. So let's label these axes too. This here was the time, right, in seconds. And this y-axis, that was h of t. That's the height in feet. So again, 0, 160, that's x, y. The x, that's time. After 0 seconds, the y value, that's the 160, that's the height. Stop recording, cancel. Don't stop yet, cancel. Alright. So when we're looking for when it hits the ground, that's going to be right there. So that is when the height, well, what's the height when something hits the ground? That's when the height is 0, right? That's going to be the y value. So we're looking for the x value, right, or the time when it hits the ground. So didn't we say this is a parabola, though? So if I draw in the rest of the parabola, well, aren't we just finding the x-intercepts, or the roots, or the zeros, right? And to do that, well, we should know how to do that. So when does the ball hit the ground? I am going to copy this equation one more time. And this time I don't want to plug in for t, I want to solve for t. And didn't we say when the ball hits the ground? That is when the height is 0. Height will be 0 when it hits the ground. So this h of t, which represented the height, I'm going to replace that with a 0. And I want to solve this equation now. So how do we solve a quadratic equation like this? Well, it's equal to 0. That's good. It's in standard form. It's good, which means we're going to factor. So let's look for a GCF. All right, 16, 144, 160. They're all even. So 2 definitely goes into all of them. 4 divides into all of them also. 8 divides into all of them. And 16 is going to be our GCF actually. All right. So 16 divides into all those numbers. My leading coefficient here, that's negative. It's a negative 16t squared. So whenever that's negative, whenever the first guy is negative, you want to factor out a negative as part of our GCF. So I'm going to factor out a negative 16. And I would be left with, well, when factoring out a GCF, you want to think negative 16 times what will give me the first term, negative 16t squared. That will be negative 16 times t squared. Negative 16 times what is going to give me 144. So you can do 144 divided by negative 16 to figure that out. That's going to be negative 9. And then we still need a t. And 160 divided by negative 16 is negative 10. Right? Negative 16 times negative 10, of course, is positive 160. And we got to check inside that parentheses. Can we still keep factoring? Yes, we can. Right, that's a trinomial. My a value here is 1, so I don't even need to use AC method. I can just do normal trinomials. Right? When we want to factor something like this, we're looking for 2 numbers that multiply to the last guy, negative 10, and add up to the middle here, which is negative 9. So I think that's going to be positive 1 and negative 10. So that's t plus 1, t minus 10. And now t'ing this off. Right, this negative 16 is not going to give us any solutions. Negative 16 can't equal 0. But t plus 1 could equal 0. That's going to equal 0 when t equals negative 1. T minus 10 could equal 0. That is when t equals 10. So we got two answers, -1 and 10. So what the heck does that mean? Well, the -1 part, that doesn't really make sense because we're starting at time 0 here. But if we drew out the full parabola, yeah, it makes sense why we're getting a second answer, because that's going to be at -1, but that's going to be at 10. And that's the answer we're really looking for, right? The positive answer. So it's going to hit the ground after 10 seconds. So after 10 seconds, we kind of have to reject that negative answer because it doesn't make sense in the context of our problem. So it's kind of mean, but we cross it out, and we're going to write the word reject. And we're only going to keep the positive t = 10 answer. Right, so I actually have a graph here, so let's do way better than the sketch, and let's start graphing. So the first point we found was 0, 160, right? That was the initial height. So let's plot that point. When we plugged in a 1, we got 288. So I'm going to plot 1, 288 also, approximately. Right, we found also the point 3, 488. I keep saying 488, 448. 3, 448 is going to be really close to 450. And then we just found it hits the ground after 10 seconds. So there's 10 seconds, that's when it hit the ground. And really important, let's label these axes like we did earlier. This here is the time, right, in seconds. The y-axis here represents h of t, the height as a function of time, and the height that was in feet. Alright, so next, let's find the axis of symmetry. Well, we know the axis of symmetry is directly in between the two zeros. So that's in between -1 and 10, right? I'm not going to include the -1 as part of the graph because we're not going to consider negative time here. But it can still be used to help us find the 0. So what's in between, or halfway in between -1 and 10? Right? Because we know the axis of symmetry, well, it's symmetrical. So if those are two zeros, it has to be halfway between those two zeros. So if you're not sure what's in between -1 and 10, let's average the two numbers. So we add the two numbers together, divide by 2, just like you would find the average of two test grades, and we get 9/2. And that's equal to 4.5. This asks for the equation of the axis of symmetry. So the equation of the vertical line is x equals. And so the equation is x equals 4.5. Alright, so I'm going to go to 4.5. And I know that is where my axis of symmetry is. X equals 4.5. Right, so letter E, using the graph, at what time does the ball hit the ground? So if they ever gave you a graph first, and there was this point, right, that's going to be your x-intercept, your 0. We did it earlier, but it hits the ground clearly after 10 seconds. Right, when the height's 0, after 10 seconds. Right, using the graph, when does the ball reach its maximum height? Well, I have the axis of symmetry here. I know the max height somewhere gonna be somewhere on this axis of symmetry, whether it's there or there or there, right? And so to find the max height, well, let's plug in 4.5. After 4.5 seconds, that's when it reaches the max height. So one more time, I think I still got it. Yes, it's still here. If I copy and paste this equation one more time, to find when the graph reaches its max height, I'm going to plug in a 4.5 in for t. And making some space. And I can leave it as red. So h of 4.5, 4.5, 4.5. Alright, take a second, type that into your calculator. H of 4.5 is going to equal 484. So this point right here, 484. And that's a really important point, so I'm actually going to label the coordinates of this guy 4.5, comma 484. Alright, so at this point we can connect all the dots, and that would be a very nice parabola. I don't have a lot of points though, but I know if that's my axis of symmetry by symmetry, if that's a point, then that's also a point, right? And if you want to just make sure, you can plug in a 6, and you should get whatever that is, the same height. Right? If this is a point that is 1, 2, 3.5 boxes away, so that's half, 1, 2, 3.5 boxes away. Right? We're going to have a point there also. And at 0, it means we're going to have a point here. What happened to my point? Point there. Good. And connect the dots. That is a graph of the height of the parabola given any time t. And there we go. Beautiful. Alright guys, you know I always struggle with this, so and boom. So if we're just graphing the equation without anything, right, we normally draw arrows to make it go on forever, but in context, right, the ball's not going to smack through the ground and reach negative heights, so we're going to stop right over there. And letter G, how can we find the maximum height using the equation? Well, we just did that in letter F. I don't actually even know why I have letter F as a question. So that is how we can plug in the value of the axis of symmetry, right? Because we know the vertex is at the axis of symmetry. And so, really important, the vertex here represents the time when we reach the max height, right? And the actual max height, 484 feet. So over what time interval is the ball rising, and over what time interval is the ball falling? So now that we've done all of this, we can kind of analyze our graph a little bit. So where is the height of the ball increasing? Well, from here to there, it looks like it's increasing, right? So that's from 0 to 4.5 seconds, right? Between 0 seconds and 4.5 seconds. So ball rising, 0 to 4.5. And where is it falling? Well, it's going to be falling in this portion I'm highlighting red. Right, the height's decreasing from 4.5 seconds up until 10 seconds. And so 4.5, comma 10. And again, it doesn't matter whether you include these or not for these intervals. You can also write it in this notation if you want. And again, it doesn't matter whether you include, so you can do or equals to or not or equals to. If you're writing it this way, make sure you used t for time, though. Alright, cool. So that was it in context, right? These things that we've been finding, they have real-world meaning. This vertex we found, that tells us the max height. Oh, that's pretty important to know for something, right? And also tells us the time when it reaches the max height. That was our vertex. When we found this x-intercept, or the 0, well, that represents the final destination of that ball, or when the ball hits the ground. So factoring we did to find the zeros, right, which ends up being when the ball hits the ground, and finding the vertex, that was the max height, and when we reached the max height. Alright, So I got one more problem over here, but I think I will let you guys try this one. Alright, I will post a answer key to this, but I do want to get you started with it, and I'll have you guys finish it and you can check with the answer key. But on this one, the path of the angry bird pictured above can be modeled with that equation. Hopefully you guys still remember angry birds. And I changed this back and forth like 3 times, and I ended up using the wrong variable here. H of t equals -5. That should be t squared, sorry. That should be 14t plus 3, where t represents the time in seconds. H of t represents the height of the angry bird above the ground in meters. So, draw an x and y axis on the diagram. What does the x-axis represent and what does the y-axis represent? So, I think I'm going to draw, again, my y-axis right through the slingshot, and I'm going to make my x-axis the ground here. That doesn't look very clear, so let me try yellow. Alright, that looks pretty good. Right, so this x-axis here, that's going to represent, again, the time in seconds. Right, and h of t represents the height. So this here is going to represent the height. And I think this time it was in meters. So find h of 0 and h of 1. What do these values represent? Again, we're just going to plug these in to our equation over here. Right? H of t equals -5t squared plus 14t plus 3. So when you plug in a 0, well, that's going to give you this coordinate right over there. Right, when we plug in a 1, that'll be after 1 second. We don't know where that is quite yet because I don't know the scaling. But after 1 second, it's going to be at whatever height, etc. Alright, and when does the angry bird hit the ground? Same as above with this one. We wanted to find where it hit the ground. We were looking for the 0. So if I'm looking for the 0 here, this one's a little more challenging, which is why I wanted to get you guys started with this one. That means I want to solve this equation. Right? When does it hit the ground? When is the height, h of t? When is that going to be 0? So to solve this, again, we have to factor. And this time, it's a little more challenging because there's no GCF I can pull out, and we have a -5 as a leading coefficient. So we have to use AC method. So the thing is, before we do AC method, I do not like that guy in front being negative. So I would recommend factoring out that negative. Or another option is you can actually move everything to the other side. Right? I could add 5t squared to both sides. I could minus 14t on both sides. I can minus 3 on both sides. So I'm actually going to do it that way. I'm going to move everything to the other side, so it's going to become positive 5t squared minus 14t minus 3 equals 0. And just like that, that negative disappeared. Right? The same thing would happen if you factor out a -1. Then you'd kind of just ignore the -1 after. Alright, so when you have a negative, those are some ways to deal with it. You can factor it out, or you can move everything to the other side. And now we should be able to solve this. Alright, so in case you forgot, that leading coefficient is a 5 that's bigger than 1. So you'll want to use AC method, right? You want to do A times C, which is -15, 5 times -3. Think about what multiplies to -15 and what adds to -14. Right, you're going to split up the middle, finish factoring, and you're going to solve for t. You know what? I think I'm just going to finish this with you guys because we've already done this much. So when does the Angry Bird hit the ground? Let's finish factoring this. I was thinking of stopping right there, but let's do this. So multiply negative 15, that's to negative 14. That's going to be negative 15 and positive 1. Right? It's negative 14t, so it's negative 15t plus positive 1t minus 3. That's equal to 0. Factor by grouping now. First 2, second 2. GCF of the first 2 is a 5. 5 and 15 have a 5. They also both have a t in common. That's going to become t minus 3. If you see we have a t minus 3 right there, right, there's no GCF. You take out just the 1. T minus 3 equals 0. T minus 3 in both sets of parentheses. We can take that out as a GCF. We have 5t plus 1 left over. Bam. T it off. T equals 3. 5t plus 1 equals 0. 5t equals negative 1. And t equals negative a fifth. So those are two zeros here. And again, we only care about the positive answer because in this context, we're not going to do negative time. But that would also make sense, right? If we extended this parabola, right? That's going to be negative a fifth, or negative 0.2 seconds, which we found. But when does it hit the ground? That's after 3 seconds. Right, so after 3 seconds, that's the point we just found, 3, 0. All right, what is the max height the Angry Bird reaches, and when does it reach this max height? So it's going to reach its max height right in the middle, right over there. And a lot of people are going to take half of 3 and get 1.5 and say it's going to reach its max height at 1.5. But remember, our other 0 was not at 0. The other 0 was at, let's use red, negative 0.2. Right? So if you want what's in between negative 0.2 and 3, let's take the average of those two numbers. Negative 0.2 plus 3 and divide it by 2. That's 2.8 over 2, and that's 1.4. Right? So our axis of symmetry here is actually at 1.4. And so if I want the vertex or the max height, I know after 1.4 seconds, it's going to be right here at the vertex at the max height. To figure out what the actual height is, all I have to do is plug in that 1.4. So if I copy this equation, bam, paste it here, we are doing h of 1.4. And that would be negative 5 times 1.4 squared plus 14 times 1.4 plus 3. Alright, I'm going to type that into my calculator, and let's see what we get. Negative 5 times 0.4 squared plus 14 times 1.4 plus 3. And that is equal to 12.8. So what is the max height? The max height is equal to 12.8 meters. And when does it reach the max height? It reaches it at 1.4 seconds. Alright, so that is it. That was some of these problems in context. Right, so a ball through the air, a football, a soccer ball, a basketball, an Angry Bird. Right, things that are thrown through the air follow the path of parabolas. And in these objects, whatever we're throwing through the air, whether it's a guy throwing this ball through the air, right? Important points on this parabola are the vertex. That's going to represent the max height and when we reach the max height, right? And when it hits the ground, well, that's the 0 or an x-intercept. And we get those by factoring, setting our equation equal to 0, right? And using the zero product property. All right, so that's going to be it for modeling today. And we will definitely practice a lot more of this. Again, if you have any questions, just send me an email, and I will see you guys soon. Have a good night.